What are circular functions? Circular functions convert angles to lengths, such as heights. The circular functions we are looking at in this video are called sine and cosine. Before we do anything, let's make sure we know what angles measure. Here is a Dalek. It is pointing to the right. Now the Dalek rotates to point in a different direction. For this example, it rotated 30 degrees anti-clockwise. Angles measure rotation. In this case, 30 degrees of rotation. Many things in life rotate and affect heights or lengths. Ferris wheels spin, and the distance from the ground of people riding on them goes up and down. The earth spins, and tides make the water depths go up and down. For these examples, we can calculate heights using the circular function sine. You have probably used sine, cosine and tangent to convert angles to lengths in trigonometry. Sokotawa. But where do they come from? Your calculator uses a complex formula to calculate these values, but we could just measure the correct values. All we need is a protractor and a ruler. For example, let's find the sine of 30 degrees. Make a circle with a radius of 1. Measure the angle 30 degrees from the horizontal axis. We will always measure anti-clockwise from the horizontal axis, or x-axis. Measure the height of the blue line. You will get 0.5. This is the answer to sine 30 that your calculator also gives. This agrees with trigonometry because in this case sine theta equals opposite over hypotenuse, and the hypotenuse is worth 1 as it is the radius. Now let's rotate the radius line segment and see what happens to the height or sine value. You can see that it increases to a maximum value of 1 at theta equals 90 degrees, decreases to 0 at 180 degrees, continues decreasing to minus 1 at 270, and back to 0 at 360. From then onwards, it repeats the same cycle potentially forever. Now, let's take this information and make a graph of y equals sine theta. The horizontal axis now measures the rotation in the circle, and you can see how the height goes up and down as the angle increases. Let's look at a set of angles that give the same sine value. For example, sine 90 equals 1, but so does sine 450 and sine 810. Just keep adding 360. This is a critical thing about circular functions. The values for sine x repeat with a fixed period. In this case, the period is 360 degrees. The shape of this graph is the shape of the most basic waves in nature. For example, radio, microwave, light, gamma, etc. Now let's examine cosine, which is shown as the red line. It changes in a similar way to sine, except that its initial value is 1 when the angle, or theta, is 0. You can see that it has the same shape as sine, just with a different starting point. It has the same maximum value of 1 and a minimum value of minus 1, although not at the same angles as sine. You might have also noticed that the coordinates of the point on the circle are cosine theta and sine theta. In summary, angles measure rotation. Sine and cosine convert rotations into lengths. Thanks for listening.